Hi everyone. In this video lesson, you will be introduced to matrices. Okay, so you're gonna learn how to go from systems to matrices or from matrices to systems. So this will be part one of this lesson. So what is a matrix? A matrix is a rectangular array of numbers enclosed in brackets, such as this example here. So notice they're always named by a capital letter. So in this case, this is the matrix A. And these arrows are pointing to the rows. So this is one row, this is two rows, right? And these arrows are pointing to the columns. So this one is, these are the columns. And the numbers inside of the matrix are called the elements. And those are the individual numbers as you see them here. Then the dimensions of the matrix, you count the rows and the columns. So for example, this matrix has 2 rows and 3 columns. So then we call this matrix a 2 rows by 3 columns matrix. So with that said, that is your introduction to matrices. So part A, representing the system with a matrix. So what if they give you a system, okay, and they want you to convert the system to a matrix? So before we do any of this, we need to make sure that the equations are written in standard form. So that means we must have ax plus by is equal to c. Okay, so what I'm going to notice first is I'm going to look at the first example, and I'm going to make sure that the two equations are in standard form. So I see a is 2, b in this case is 1, and c is 9. So ax, by, and c. So that means this equation is in standard form. Both of them are standard form. So then what I'm going to do is I'm just going to look at the coefficient in front of the x, the y, and I'm going to see the constant here. Okay, so then I'm going to open a brace or a bracket, and then notice that the coefficient of x is 2, the coefficient of this y is 1, the constant is 9. Okay, so that's the first equation. The second equation, coefficient of this x is implied to be 1, coefficient of y is -6, and the constant is -1. So this is how you go from a system of equations to a matrix. So in this case, this matrix is a 2 rows by 3 columns matrix. Okay, so it's that simple. So for example number 2, for this one here, I have to make sure again that they are in standard form. So in this case, we have 3 variables, so we should have in alphabetical order x, y, z. Okay, so if I look at the first equation, this one is done. If I look at the second equation, I don't see y value here. I don't see y in these variables. So what I'm going to do is I'm going to copy this one as it is. Okay, so this is x minus 3y plus z equals 6. And this one, what I'm going to do is I'm going to write a 0 for a y as a placeholder because I don't have any y's. So then this is x plus 0y plus 3z is equal to 12. And then the next equation, I don't have a z, and notice the y is on the x is on this side, so I need to bring it to the other side. Since it's negative on this side, when I bring it to the left side, I'm adding it, so it becomes 5x plus y plus there is no z, so that means 0, z equals, the constant is 1. Okay, so again, if you don't see a variable, then just write a 1 as a placeholder, because the matrix is going to ask you to enter something, some value for that, some coefficient for that variable. So then once we have the equations in standard form, the matrix for this one is coefficient of first on x on the first equation is 1, coefficient of y is -3, coefficient of z is 1, and the constant is a number 6. Okay, so that's the first equation. The second one, coefficient of this x is 1, so write a 1, coefficient of this y is 0, coefficient of z is a 3, and the constant is 12. And then the last one, coefficient of this x is +5, coefficient of y is 1, and the coefficient of z is 0, and then the constant is 1. So this is the matrix that represents that system of 3 variable equations. Okay, all right, so what about part A? Part A says writing a system from a matrix. So notice we have 3 that always corresponds to the x. This is -1, that's y, and this is a constant. So to go from a matrix, okay, to go from a matrix to a system, So then this, you would just notice that this is a 3, so that means 3x. This is minus 1, so that means minus y, and that equals 6. The next one, we have 8x. And notice that we have no y, so you don't have to write a y here. You can just leave it like that, and then this is negative 4. So this is the system that represents that matrix. So the point is, you should be able to go from a matrix to a system of equations. Okay, so on the second part, I'll go over how to use matrices to help you solve systems of equations. Instead of using substitution and elimination or graphing, you can actually use matrices. I'll see you in the next video.